Open the map of Greece and draw a wide arc from the coast to the hills, and you land on open-air theaters carved into slopes. From the first step, you climb at Epidaurus. The acoustic agenda is obvious. Carry unamplified speech to thousands without walls or a roof. The claim is not magic. It is a stack of physical choices that make speech intelligible in the real outdoors. Start with geometry. The cavea wraps the audience around the source in a shallow bowl, shortening distance compared with a straight grandstand. Direct sound stays largely unobstructed, because every listener looks down toward the orchestra and the former stage front. Hard, continuous surfaces return early reflections toward the audience instead of soaking energy into soft ground. That combination clear line of sight and cooperative reflections pushes useful signal above background. Now consider the seat rows themselves. Limestone benches form a corrugated surface that behaves like a spatial filter. Those ridges tend to suppress low-frequency murmur from crowds, while favoring the higher speech bands that carry consonants. Listeners still perceive a complete voice thanks to psychoacoustics. When harmonics are present, the brain recovers the missing pitch. The result is not louder in absolute terms. It is cleaner where speech information lives. Add the theater slope. The rake ensures that each head is above the one in front, reducing shadowing and multiple body absorption between source and listener. It also angles ears toward the source, aligning listeners with early reflections arriving from the orchestra floor and the Skene facade that once stood behind it. Early reflections within the first few dozen milliseconds reinforce direct sound without smearing words. Ancient builders did not talk in decibels, but they learned to capture these effects by habit and test. Actors helped the system by projecting with trained breath, masks, and rhythm built for outdoor space. Projecting does not mean shouting. It means focusing energy into the consonant band and keeping timing sharp for the audience's brain to parse. So why does the myth of perfect acoustics persist? Whispers audible in the last row, and pins dropping like drums. Modern measurements show a cooler truth. Unamplified speech with good projection is intelligible far up the cavea, but a soft whisper is not. The theaters are good, not supernatural, and that is exactly what robust engineering looks like. Seats explain much of the filtering, but they do not work alone. The orchestra floor mattered. A firm, hard surface returns a powerful early reflection up into the cavea. The Skene mattered when present. A reflective wall behind the actors kicks energy forward and adds a second helpful arrival. Even the shape of the auditorium matters twice. It spreads audience around the source and distributes reflections more evenly than a flat field. Noise control finishes the story. A hillside site blocks external noise from behind the audience and points listeners away from windbelts and market streets. Crowd behavior was part of the design. Festivals trained audiences when to be quiet, so faint passages were not drowned. Materials were chosen for function as much as for form. Limestone is stiff and reflective. Joints between blocks are tight. Edges are crisp enough to scatter without killing clarity. Where Roman builders later favored marble veneers, Greeks worked with the rock of the hill and the poros they could shape and volume. Seat corrugation, meanwhile, is a happy accident. The theory now explains and practice long ago exploited. How do we know all this and not simply repeat guidebook lore? Researchers measured impulse responses across theaters and compared results with listening tests for speech in small sounds. They modeled diffraction from seat tiers, simulated wave fields, and checked the role of early reflections from stage architecture that no longer survives. The patterns converge. Clarity metrics for projected speech are high across much of the audience. Intelligibility drops when speech level drops. Coins, matches, and whispers lose identity halfway up. Projected syllables remain recognizable much farther. That mix of filtering, reflection, and projection explains real-world experience far better than wind or mystique. Now, let's walk the system end-to-end as if you are designing it. Place the theater on a quiet slope with the view open behind the stage, but the back of the cavea protected from noise. Lay out the cavea in concentric arcs around a circular orchestra so no listener sits far off at axis. Keep seat risers regular so the corrugation is consistent, because random steps scatter unpredictably. Size the orchestra floor to send a strong bounce toward the middle tiers, not just the front rows. Add a Skene with a broad, hard facade. Let its height stand high enough to throw energy, but not so high that it shadows the upper cavea. Keep sidewalls low or broken, so late lateral echoes do not form. Snapback control the slope, so sightlines are clean and bodies do not mask one another. Use stone where you can, and keep surfaces smooth. Roughness at the wrong scale eats the brilliance of consonants. Now run a rehearsal checklist like an engineer. Put one actor at the orchestra center, and another on the stage line, and trade lines at normal and projected levels. Walk the aisles during the test and listen for where consonants blur or vowels boom. Mark dead spots for later surface repair, and check where the orchestra reflection hits with the most benefit. Have actors face slightly above the first rows so energy launches toward mid and high seats. Use chorus movement to avoid masking key lines. Keep loud shoes off the orchestra during quiet speech. If you must set props, Avoid soft hangings near the stage front. They drink the same high bands you are trying to preserve. In performance, timing is an acoustic variable as real as level. Pause a beat after a line that ends with soft consonants. Let the last reflection land before the next word starts. Pitch sentences to keep consonant energy forward. Long vowels do less work outdoors than crisp onsets. A mask's mouth opening and material can help by focusing energy like a tiny horn. It will not replace projection. Audience absorption is both friend and foe. People dampen harshness and late scattered sound, which improves comfort. They also reduce gain at the back, which actors must overcome. Directing and acting styles grew around those constraints. The acoustic grammar shaped the drama's vocal grammar. What about resonance vases? You sometimes hear about bronze or clay jars hidden under seats. Ancient writers described them, and Roman builders experimented. Butt field evidence in Greek theaters is thin, and modern testing shows the major gains come from geometry and hard surfaces. The real passive amplifier remained the cavea and the seat tiers, not secret hardware. Season and weather nudge performance but do not rewrite physics. Warmer, drier air eats more high frequency over distance. Cooler, still air preserves it a little better. Mild breezes can bend sound or bring short-lived rustle noise, which audiences and actors learn to ride rather than fight. Night performances traded heat shimmer for quieter backgrounds. Day shows carried on the discipline of clear projection. If you stand today at Epidaurus and try the famous tricks, the results match the measurements. You will hear a coin or paper far away as a tick, not as a story. You will hear a whisper only nearby. Give a well-projected line, and the last blocks will still catch it. That is a better tale than myth because it respects both the builders and the physics. The system works because everything points the same way: geometry, materials, performer craft, and audience discipline. That principle survives even when the stage building is a ruin and some surfaces are rougher than in antiquity. Add back a reflective Skene in a model, and you gain a few precious decibels where you need them most. Take away the seat corrugation in a simulation, and you lose the very filtering that keeps murmurs down. Change the slope too much, and heads start shadowing, pulling clarity from the upper wedges. What you are seeing is a design space explored over generations by trial, error, and memory. Builders validated what worked by what audiences rewarded and what actors could sustain. Acoustic success needed no modern formula. It needed consistency and feedback across many festivals. Consider what the audience actually heard at scale. Direct sound first, then a tight early reflection from the orchestra, then a well-timed return from the Skene, or the first seat risers behind them. Most of the late energy vanished into the sky, leaving speech clean and close, with little lingering tail. That profile keeps rhythm crisp for choral odes and dialogue alike. Theaters differ, and Epidaurus is not every site. Some venues had stronger winds, different stones, or altered Roman stages that changed the reflection pattern. Yet the core recipe repeats: wrap the audience, harden the launch surfaces, corrugate the seats, train the voice. Modern venues borrow the same logic with reflectors, diffusion, and targeted absorption. Ancient practice arrived first by making the hillside itself a device. Engineers looking for a single secret will miss the ensemble performance. Seats filter noise and emphasize consonants, the slope opens sight and sound, the orchestra and Skene feed early energy, and actors supply the rest. When all four align, even a very large open-air crowd hears the story clearly without electronics. That is the real answer to how Greek theaters achieved what they did. Not perfection, but a tuned system that privileges intelligibility where it matters. And that answer scales from a coin and a whisper that become myth, to a chorus that becomes music. Two words that still land in the last row when a human voice is asked to work. Use that lens and the theater stops being a miracle and becomes a manual. Build with gravity, stone, and geometry. Perform with breath, timing, and consonance. Keep the audience quiet when it counts. The physics will do the rest.